Assalamualaikum, sir. Can you hear me? Hello, can you hear me, sir?
Assalamu alaikum. Can you hear me?
Walaikum assalam. I can hear you, sir.
Okay. Sorry. We are keeping this class for a quick revision of kinematics, and obviously the May has started. Many people have. I think you also have a paper tomorrow, the first paper. First of all, good luck for that. And secondly, I think you have all the chapters done with me except kinematics and measurement. Measurement is an easy chapter, and you can always tell me whatever query you get in any chapter, anytime you always text me. You can always inform me and just give a new heading, kinematics.
Done, sir.
Now, this is a very important chapter, and we are making a quick revision of that chapter. The contents of this chapter are basic terms in kinematics, equation of motion, sketches in kinematics, projectile motion. Kinematics is the study of motion and rest without considering the forces involved. Actually, kinematics and dynamics, they together form a block and they normally come together. It's a common question involving kinematics and dynamics together. So you have to copy down this as a start of the topic. We do not need much. We can't make long notes now. So we have to make some quick sheets so we can get this chapter back.
Done, sir.
Now, these are the main types of motion. There are two types of motion. One is called linear motion, like a car traveling on a road. And second is a non-linear motion. This is actually the main scope of this chapter. So this chapter is divided in two portions. First is the linear motion and second is the non-linear motion. Linear motion is of two types, horizontal and vertical, and non-linear motion means projectile, like a football kick. So you have to copy this.
Done, sir.
Important terms which you have to learn in this chapter: distance, displacement, speed, velocity, and acceleration. These all definitions are important, especially velocity and acceleration and speed. Distance and displacement do not come regularly. So you have to make this copy.
Done, sir.
Now, what is the definition of distance? Distance is a scalar quantity. Distance is the length of any path between 2 points. What is displacement? Displacement. What is displacement? Displacement is the shortest distance. What is definition of speed? It is the rate of change of distance. What is velocity? It is the rate of change of displacement. And what is acceleration? It is the rate of change of velocity. I hope you remember all of them. I just want you to see them orally, and there's no need to copy it. And you just see them orally.
Done, sir.
Now, look at this. Look at these few ideas which are also very important. First, we look at this idea that if you come back to the same position, displacement becomes zero. The resultant displacement becomes zero. As soon as you take a U-turn, the velocity becomes negative. Sign of velocity reverses when the direction of the motion reverses. Displacement is a vector quantity. Displacement is a vector quantity. It does not become negative when you take a U-turn. You can see this diagram. It's a U-turn case, but you can see here the object has not taken a negative displacement. Displacement becomes negative only when you go beyond the starting point. So suppose you are coming back to your home and you by mistake goes a bit ahead. So in that case, your displacement would be negative. These points are very important, and I will share the link of the link of this file with you after the class, inshallah, so you can view it whenever it is needed. When velocity is zero, acceleration is maximum. When velocity is maximum, acceleration is zero. It's a very interesting reverse rule, and you are taking maths also, you can remember it, that when you differentiate velocity, you get acceleration. When you differentiate velocity, you will get acceleration. That is why velocity is zero when acceleration is maximum. Velocity is maximum when acceleration is zero. Velocity is minimum when acceleration is zero. In mathematics, maximum or minimum is called a stationary point. You must remember the stationary point where the derivative is zero. Now, this is a very important sheet. There are two types of acceleration, uniform and non-uniform. Now, uniform and non-uniform means if one number is being added, suppose velocity increases or decreases by 2, 2, 2, it is uniform. If velocity changes with different numbers, sometimes it increases by 2, sometimes it increases by 4, it is non-uniform. There are two further types, acceleration and deceleration. With non-uniform, there are also two types. There is a formula which is very important to remember, the formula for acceleration if it is uniform. Now, you have to copy down this screen.
Done, sir.
Now, this is a technical concept, and even though it does not come every year, it should be remembered. And the concept says that velocity is a vector. Acceleration is also a vector. When you take a U-turn, suppose you throw a ball upward and the ball comes back, it is called a U-turn. Velocity immediately becomes negative. In O level, many people think that whenever velocity decreases, it is a retardation. It is not right. Acceleration means velocity increase and deceleration means velocity decrease, but velocity itself can be positive or negative. In our O level, we had a concept that negative acceleration is always retardation. This is wrong, and you can see in this sheet. As I said, I will share the link with you and you can revise it when it is needed, even because it's a very important chapter. And it needs quick revision always. Now, these are the equations of motion, and I hope you remember all of them very well. There are two assumptions in using these equations, which are on the side. Just go through them orally.
Done, sir.
Now look at this concept. This is called free fall. Free fall means no air resistance. The acceleration of free fall for a body near to the earth is constant. So if there is no air resistance, everything will fall due to gravity only. And this is called free fall. Now, this is a very interesting diagram. It comprises many important concepts. Gravitational acceleration G has two possible translations from our O level. It is called acceleration due to gravity. It is also called gravitational field strength. Now you have to copy this screen. Have you copied it?
Yeah, now done. Done, sir.
Good. Some important points of this sheet. At the highest point, which is the turning point of the motion, at the highest point, acceleration is maximum because there is a U-turn, but velocity is zero because the object will stop. Now, second important feature you should see that velocity here, velocity is positive, and as soon as you take a U-turn, velocity becomes negative. As soon as you take a U-turn, velocity has become negative. Now, as you move down, velocity remain negative. But as soon as you crosses the level of the cliff, you will see displacement has become negative. Acceleration is still negative. So in a U-turn motion, acceleration is negative throughout. Now, what are the two meanings of acceleration? When something is falling freely under gravity, it is called acceleration due to gravity. And suppose we are sitting and we are attending a class. For us, gravitational field strength is the strength of the field. It is just like the Wi-Fi, just like the Bluetooth, and the strength of the field means the signal strength. How much gravity is strong there. Now, falling with air resistance, when something is falling with air resistance, this is called a drag force. Air resistance is always opposing the motion. Air resistance is always opposing the motion of the object, and this is called a drag force. When the air resistance gradually increases and it equals the weight, air resistance equals the weight, resultant force becomes zero, acceleration becomes zero, and velocity becomes constant. This is the famous concept, one of those concepts which come in every paper, and it is called terminal velocity. So when an object falls through air or any other fluid, its acceleration decreases until the acceleration becomes zero and velocity becomes constant. This concept comes in every paper, nearly every paper. You have to copy down this concept.
Done, sir. Are you saying something, sir?
Hello, are you able to hear me?
Yeah, now I can.
Okay, sorry. Now, this is the most important sketch in our past papers, and you can find this sketch many times. The sketch shows that velocity is increasing at a decreasing rate. When the line becomes horizontal, velocity becomes constant, and this is called terminal velocity. Acceleration versus time. This sketch shows that acceleration decreases until acceleration becomes zero. You have to copy down this screen.
Done, sir.
When a paratrooper jumps, a very common example of this topic, the paratrooper does not open the parachute immediately after the jump. The paratrooper goes down, and the upthrust is upward, and the velocity increases at a decreasing rate. The paratrooper reaches terminal velocity, then he opens the parachute, the velocity decreases, and due to parachute upthrust, the paratrooper gets the second terminal velocity. This is a famous sketch of paratrooper. Similarly, when a car is traveling on a road, driving force faces air resistance. Weight and normal reaction are facing each other. Driving force is competing against friction and air resistance. Gradually, the car reaches terminal velocity. What's the meaning of terminal velocity? That the resultant force at this point, the resultant force becomes zero. This is the point where resultant force becomes zero. Now, these are few important sketches, and you have to remember them. Look, sketch is something which is the very important part of our AS physics. This is the first chapter in course where sketches come. So these are the fundamental sketches which should be learned by heart from mathematics and physics. So copy this screen.
Done.
Now, these are the main parameters for sketch. Whenever you come across a sketch, you should first see the gradient, then the area, if it works. Third, what the Y quantity is showing. Number 4 feature, plus or minus, turning point is a very important feature, but in physics, it's not very common. In maths, it's common, but in physics, normally gradient and area are the main feature. Derived functions. What's the meaning of derived functions? That, for example, force and acceleration are directly proportional. So the sketch, so the sketch of force is the same as the sketch of acceleration. They are called derived functions. Now, if a line is parallel to x-axis, gradient is 0. If a line is parallel to y-axis, it's an infinite gradient. If a line is on the x-axis, value of y is 0. You have to copy down this.
Done, sir.
Now, these are the 4 important shapes. Remember, whenever you come across a sketch, always try to handle the sketch with the gradient. Now, these shapes are very important because they actually tell you what the graph is doing. Negative gradient means that when you draw a tangent, it will be sloping to the left, like a bridge coming down. And positive gradient means if you draw a tangent, it will be going up like the start of a bridge. Now you have to copy down this very, very important sheet.
Done, sir.
Now, gradient shows the ratio of y to x. So if it is displacement against time, speed is increasing. If it is voltage against current, resistance is increasing. This is considered to be, in our physics, this is considered to be the second most repeated sketch. It has appeared so many times. And how we say resistance is increasing? Because the graph is going upward, it is bending towards voltage. And if you remember these 4 sheets, you can easily identify you can easily identify that gradient is increasing. This is the benefit of learning those sheets. Area under a sketch shows the product of two axes. For example, velocity time graph, distance travel, a very famous concept. It also appears nearly every year. Now, these are the 6 main sketches of distance time graph. Normally, distance time, velocity time, speed time sketches come in the paper. So you always have to carefully see what the sketch is titled. It is a distance time graph because shapes always match. You have to copy down this.
Done, sir.
Now, you can see the first sketch is a straight line. When it is a straight line, remember the gradient is constant. As I mentioned, there is no need to learn these sketches. You actually should learn this sheet, and this sheet. If you learn these sketches, you can manage all the sketches. Because, for example, the second sketch, if a line is parallel to x-axis, the gradient is 0. It means it is a rest position. When the graph is coming down, velocity is increasing because gradient is increasing. When the graph is going up, gradient is increasing. So these are the 6 important sketches. For example, a ball is thrown upward, later it falls down. It's a free air with no air resistance case. Now, gradient at the turning point is 0 here. It means at the highest point, velocity will be 0. For when it is going upward, velocity is decreasing for the upward motion. And for the downward motion, velocity is increasing. Now, velocity time graphs, you have to copy them. And obviously, velocity time graphs or speed time graphs are very important in this chapter. But again, no need to learn these sketches, learn those sheets.
Done, sir.
Now, if you see, you will find the same rule. Sorry. If the line is parallel to x-axis, gradient is 0. Gradient is acceleration, so acceleration is 0. Now you can see that velocity has some special feature. Velocity can be negative. Many sketches in the past paper, you can find that velocity has become negative. You can see acceleration is negative because the line is sloping down. Whenever velocity decreases, it is a retardation case. At this point here, velocity is 0. It's a case of U-turn because in U-turn, velocity becomes negative after the U-turn. So in a velocity time graph, velocity can become negative. Now you have to give a heading, derivations of equations of motion. This is a rare topic and it comes very rarely.
Done, sir.
Now you can see this one. This is a standard derivation because if it's a velocity time graph, its gradient will be v minus u upon t minus u. This is the first equation. Derivations are memory cases. Whenever you get a derivation, you have to copy it, you have to paste it because it is not something of common sense, even though logic is always there, but you cannot derive it on your own. So this is the first derivation. This is the first derivation. Copy it. And if you have any query, you can ask me.
Done, sir.
Now you have to see the second derivation, velocity against time. This time the graph is giving the area as the distance. V is equal to u plus at because you're a math student. So you should know it's a substitution case after the area of a trapezium. Area for trapezium is half into base into sum of parallel sides. So you have to copy this second derivation.
Done, sir.
Now, the third, the famous equation, v square is equal to u square plus 2as. By definition, it is a is equal to v minus u upon t. We first make this equation. Then distance is equal to average velocity into time. If you observe from here, now if you compare the two equations, you will get, if you compare the two equations, you will get the mean final equation. You have to copy this.
Done.
Now, when you find the gradient, you should take the furthest points. You should take the points as far as possible. The gradient of velocity time graph shows the acceleration. Acceleration, for example, here is 2. Velocity time graph, the area under a velocity time graph shows the distance traveled. It can be triangle, it can be a trapezium. Now, this is a very tricky part, as I said in another class before that, it is a case of box counting. Box counting means that you have to count the bigger boxes, you have to count the smaller boxes and make their areas. This is a very, very challenging question, but luckily it doesn't come every year. Actually, area under a curve requires this box counting method. Now you see this is sketch. The first part, velocity increases at an increasing rate. Then if you travel A to B, you can see the line is straight. It means acceleration is constant. Velocity is increasing at a constant rate. Now, there's a very important sketch that if you draw speed, speed can't be negative, so the graph won't go in negative. In a velocity time graph, it can be negative. Just look at these two sketches. No need to copy them. As said, I will share the link, inshallah, and so that you can view it on my channel. So these are the two important comparative sketches. The trick is there that speed time graph cannot go in negative. Velocity time graph can be negative. Just view it.
Done, sir. So,
Interconversion of, sorry, yes, are you, do you want to say something?
no, sir, it's fine.
Okay. Interconversion of sketches, and you can see the left-hand sketch, displacement against time, which is a uniform velocity. And when you draw it on velocity times sketch, it will be a straight line. What this topic is showing, that you can convert one sketch into other form. You can convert one sketch, you can observe. This is a case of rest. Velocity is 0. And this is the second one, decreasing speed. Gradient is decreasing and the graph is coming down. Increasing speed. This is a graph which is bending upward. Now, let's start the second part of this chapter, which is called projectile motion. Projectile motion is an example of two-dimensional motion, like when you hit a football, like when a military launches a missile. It's a two-dimensional motion, a horizontal and a vertical. There is a uniform acceleration in one direction and uniform velocity in perpendicular direction. So now copy this screen.
Done, sir.
Now there is an assumption. There are few assumptions which you have to learn. This is a famous diagram of projectile motion. At the highest point, kinetic energy and momentum both are not zero because object is moving. At the highest point, the vertical component of velocity is zero. There are three important assumptions. The first assumption is very famous, that air resistance is negligible. Air resistance is negligible. The value of G remains constant throughout the motion. So you have to copy down this.
Done, sir.
Now, formula for resultant velocity. This formula is very important, but majority people forget it. In a projectile motion, if you see, whenever you talk about a projectile motion, there are two velocities, vertical velocity and horizontal. If you combine them, you will get a resultant velocity V. V. This V is called resultant velocity. Vx is equal to V cos theta, which is a very common question, but the Pythagoras formula is not very common. So you have to copy down this screen.
Done, sir.
Now, at the highest point, the vertical component of velocity is zero. You can look at it here, there. This is the highest point. At this point, the vertical component of velocity is zero. And second, vertical component first decreases to zero and then increases. If you look at here, look, this is the vertical component. It's decreasing, getting smaller because gravity is opposing it. Angle of the launch is the same as the angle of strike. You can observe here, this is the angle of launch and this is the angle of strike. If it is a straight surface, the two angles are equal. So you have to copy this important sheet.
Done, sir.
Throughout the motion, a very important concept when a projectile motion is there, you can see here, this is called horizontal component. As air resistance is negligible, so the horizontal component throughout the motion does not change. But the vertical component is affected by gravity, so it changes. Now, horizontal component of velocity remains constant while its vertical component changes. It's a very important and very helpful summary of this very challenging topic. Projectile does not come every year. But in recent past paper, you can find that this topic is coming very regularly. Otherwise, dynamics is always there. So you have to copy down this final very important sheet of projectile motion.
Done, sir.
Okay, so we have done this chapter, and this was a quick review of the chapter as mentioned. I will try to share a link with you so you can revise this chapter. All important notes we have already written. So this chapter was kinematics. It included projectile. So we'll continue in our next class. As I mentioned on my message, that now there is no permanent timetable and everyone has to look his or her own schedule. And I'm always available for any query, for any guidance. My channel is also there, website is there. And the main target is to follow the timetable of the students now, because everyone is having different paper. I think you have 4 subjects, so you have to make a very strong schedule. So good luck for the paper tomorrow. And inshallah, we will discuss the new things next time. Allah Hafiz.
Thank you so much, sir. Allah Hafiz.